Hi students, welcome to exercise 26B, exponential equations with different bases. Okay, so in this exercise, we're going to solve exponential equations. So notice 3 to the power of x, x is your variable. But in this case, unlike exercise, I believe 22, 3 and the 8 cannot be changed to the same base. So different bases. All right. Although, we can probably guesstimate what the value of this is. Since we know that 3 squared is 9, it'll be a little less than 3 squared, right? So a little less than 2. So although we do not know the value of x, we can estimate that x is approximately equal to 1.9 since 3 squared is equal to 9. Okay, so to access the exponent, so what we want to do is solve for x. We're going to use the log function. So remember the third law of logarithms is the power rule, is that I can drop the exponent in front of the log. Well, that's how we're going to get at that exponent. So what we're going to do is in this type of equation, okay, when we can't change the base on both sides, I'm going to take the logarithm of both sides. All right, so what that's going to do, it's going to allow me to drop the x in front of the log because it is the exponent of the argument. And what I'm left with is this. Well, now, in this formula, I can actually solve for x by dividing by log 3 on each side. Notice that the base is 10 because I can evaluate that. So these log 3's can cancel out. And what I have left is x equals to log 8 divided by log 3. And this is something you can enter in your calculator. We've talked about this, I believe, in exercise 25. So then what you do is you take out your calculator and you do log 8 divided by log 3. And it gives you, and I'm going to again write it to 4 decimal places, and I'll just chop it there, 1.8927. Okay, so notice that that's pretty close to our estimation, but this would be an estimated value, but an exact value correct to 3 decimal places. So 3 to the power of this gives us 8. Okay, and next example, fairly straightforward if you look at the bases. This is base 19 and base 3. You cannot change the 19 or the 3 to the same base. So this would be an example of an equation where you need to use logarithms. So the first step is simply attach logarithm to each side. So I'm going to take the log of 19 to the power of x minus 5, and I'm going to take the log of 3 to the power of 2x plus 1. Okay, well that allows me to drop the exponent in front of the log. So now what I have is x minus 5, notice I put it in brackets, times log of 19, and I have 2x plus 1, all that times log of 3. Notice if I don't have brackets, that would be x minus 5 log 19. This log 19 is actually distributed to both. Same thing here, the log 3 distributes to both. So what I have after that is I have x log 19 minus 5 log 19, because again, the log 19 multiplies the x, so it's x times log 19, and log 19 multiplies negative 5 log 19. Okay, on the other side, same idea. You're going to have distribute that log 3, so it's 2x log 3 plus 1 times log 3, which is log 3. Okay, the next step is to get all the x terms together. Okay, so it's grouping the terms with x. So this term and this term both have a term with x. This term and this term both don't. So what I'm going to do is I'm going to bring both x terms on this side. I'm going to bring both terms without x on this side. So simply, what I'm doing is I'm going to subtract 2x log 3 on both sides. So it's subtracting 2x log 3 here. And we're going to bring plus 5 log 19 on this side. So again, it's just simply grouping like terms together. So that cancels out that 5 log 19, and this cancels out the 2x log 3. So what I have left is x log 19 minus 2x log 3. And on this side I have log 3 plus 5 log 3. Whoops, that should be log 19, eh? My bad. So and that should have been log 19 as well, right? So this should be log 19, and this should be log 19. Okay, so next thing we're going to do is we have 2 terms here. There's a factor of x in each term. So this step, and again that fabulous F word of factoring, is we're going to factor out this x, and what we're left with is log 19 And here we have 2 log 3 left. And over here I just simply have log 3 plus 5 log 19. Okay, so by factoring out this x, so here we're going to identify, so we're going to factor x. Okay, so now what I'm going to do is I'm going to divide each side by this term, because right now we have x times all of this. So by simply dividing each side by log 19 minus 2 log 3, you're getting rid of all that, and you're leaving x by itself. And so I'm going to divide this whole thing also by log 19 minus 2 log 3. Alright, so just for space, I'm going to move over here. Okay, so what do I have left? I have x equals to all this stuff. So I'm going to rewrite it log 3 plus 5 log 19. I'm trying to stay on the page here. And log 19 minus 2 log 3. Okay, so now I invite you to use your calculator. Notice that these are all log-based tens, so you can use your calculator for that. Plug that in your calculator, make sure you know how to use it, and see what comes out. What you should get is 21.1730. Okay, so make sure that you can come up to this solution. Alright, last example. A little bit more difficult of a question. Notice there's a product here, 2 times 3 to the power of x. And also note that 2 times 3 to the power of x is not 6 to the power of x. That x would have to be associated to the 2 as well. Okay, so anytime in this case, again, this base cannot be changed to this one. Okay, you can't multiply those two unless they have the same exponent. So what we're going to do is we're going to use the log. So we'll apply log on each side. So very similar to what we've done previously, but it's log of all this, right? 2 times 3 to the power of x, and here I have log. Again, if I could put brackets around it, you can. Not really necessary in that case. Okay, so now notice that you have a product here. So now with the log rules of a product, you can change that into a sum of logarithms. So that would be log 2 plus log 3 to the power of x. And here, well, there's nothing I can do here, so I'm just going to rewrite it like this. Okay, well, the next step is to simply drop the exponents in front of the log. So this x is going to go in front of the log 3, and this 3x minus 1 is going to go in front of the log 6. So what we're going to have is log 2 plus x log 3 equals to 3x minus 1 log 6. So notice again I put brackets around that because I have to show that this whole thing's in front of this log 6. And now I'm going to distribute this log 6, nothing to do on the left hand side. So I have x log 3 equals to 3x log 6 minus log 6. So notice that that's just negative 1 times log 6, which is negative log 6. Okay, so we're at the same point as we were right here in the equation, or actually one step before that. We want to bring all the terms with x on the same side and all the terms without x to the same side. So this time I'm going to bring all the terms with x on this side, and I'm going to bring this term over here. So what I'm going to have left is log 2 plus log 6, right, because I brought this term over to the other side, so plus, equals to 3x log 6. That one didn't move. And I'm bringing this one over, so it becomes x log 3 on this side. Okay, so now I've done all the x terms together, all the terms without x together. So now we're going to factor x, so same idea as we did last time. So we have log 2 plus log 6 equals to x. What do I have left? 3 log 6 minus log 3. Okay, and I will now divide each side by this term because I want to isolate x. So I divide each side by this. So what we have is log 2 plus log 6 divided by 3 log 6 minus log 3. All that's equal to x. So again, use a calculator, bring it out, see if you can get the answer, which is 0.5810 equals to x. And again, to verify that, all you'd have to do is take that 0.5810, plug it into there, and 2 times 3 to that power, and 6 times 3 times 0.58 minus 1. If each side is pretty close to the same, notice that you rounded the final answer. If each side is the same, you've kind of verified that the solution is correct. And notice since you have a calculator, you can actually verify that. So, okay, good luck, guys. Again, this is solving equations with different bases, and the variable is in your exponent.